The moon, that tranquil and luminous presence in our night sky, harbours a history far more dramatic than its calm appearance suggests. It wasn't always there. In fact, Earth's closest companion emerged from one of the most violent and cataclysmic events in our planet's history. A fiery collision that forever reshaped the world as we know it. How did a collision of unimaginable proportions give rise to the moon we know today? Today, we're diving into the mind-blowing story of how the moon came to be. To understand how the moon formed, we must travel back 4.5 billion years to a time when our solar system was a chaotic cosmic battleground. Earth was just one of many embryonic planets, or planetesimals, racing around the newly formed sun. These young worlds were in constant turmoil, colliding, merging, and evolving. Over time, Earth gradually grew by accumulating debris from smaller planetesimals and leftover material from the formation of the solar system, which bombarded it in violent impacts, eventually forming a larger, rocky planet. But it wasn't alone. Another Mars-sized object, known today as Theia, was also orbiting the Sun, and their paths were destined to cross. Around 4.5 billion years ago, Earth and Theia collided in a cataclysmic event that reshaped our planet, an event known as the Giant Impact Hypothesis. Theia, named after a Greek Titan goddess of sight and vision, and the mother of Selene, the goddess of the moon, didn't just graze Earth. It was a violent head-on collision, releasing more energy than 1 billion nuclear bombs. The impact fused the two bodies together, blasting massive chunks of Earth's mantle into space. The debris from this collision formed a swirling ring around Earth, much like Saturn's rings today. Over time, gravity worked its magic, pulling these fragments together to form a new celestial body, the moon. But how do we know this cataclysmic event really took place? The evidence is written in the very rocks of the moon. During the Apollo missions, astronauts returned with moon samples, and scientists were stunned to find that their composition was nearly identical to Earth's crust. This striking similarity suggests the moon was once part of our planet. Furthermore, computer simulations of giant impacts align perfectly with the moon's size, orbit, and density. The consistency of this data makes the giant impact hypothesis the most compelling explanation for the moon's creation. In its infancy, the moon wasn't the serene, cratered world we know today. It was a fiery, molten sphere burning bright in the night sky. Over millions of years, it began to cool and solidify. During this period, colossal meteor impacts scarred its surface, creating the craters and basins we see now. Some of these basins filled with lava, forming the dark seas that give the moon its distinct appearance. The moon's creation didn't just change the night sky, it fundamentally shaped life on Earth. The moon's gravity stabilizes Earth's tilt, which gives us predictable seasons. Without the moon, Earth's axis could wobble unpredictably, leading to extreme and chaotic climates. The moon also governs the tides, which have influenced everything from the evolution of coastal ecosystems to the migration patterns of early marine life. In a way, the moon's gravitational pull has helped guide life on Earth for billions of years. Let's imagine an alternate timeline where Theia missed Earth. Without the moon, Earth might be a vastly different place. Without its stabilizing influence, Earth's tilt could swing widely over time, causing dramatic shifts in climate. This instability could have made it much harder for complex life to evolve. The lack of tides would also mean slower nutrient mixing in oceans, potentially delaying or even preventing the emergence of life as we know it. Despite all we've discovered, the moon still holds many mysteries. For instance, some scientists believe Theia's impact may have delivered water and other key materials to Earth, setting the stage for life, while others propose these elements arrived through later impacts. Another fascinating mystery is why the moon is so chemically similar to Earth, but not identical. Did Theia contribute its own unique material, or did Earth's dominance shape the mix? Even today, researchers continue to explore the moon, hoping to unravel the mysteries of our origins. Looking ahead, the moon could play a key role in humanity's future. NASA and other space agencies are planning missions to establish permanent bases on its surface. These lunar outposts could serve as launch pads for missions to Mars and beyond. The moon holds untapped resources that could revolutionize space exploration, with water at its poles being one of the most valuable. NASA's recent missions have confirmed the presence of this ice in permanently shadowed craters, where sunlight never reaches and temperatures are incredibly cold, creating ideal conditions for water to accumulate. This discovery is a game changer for future missions, as water can be used for drinking, producing oxygen for breathing, and even converted into rocket fuel. The moon is far more than a distant celestial body. It's a symbol of the universe's boundless chaos, creativity, and resilience. Forged in a cataclysmic collision, it has shaped the very foundations of life, stabilized our planet, and sparked the imagination of humanity for millennia. The next time you gaze up at the moon, remember, it's not just a rock in the sky, it's a living testament to our shared cosmic history and a powerful reminder of how deeply connected we are to the universe. As a sole creator, I truly appreciate your support. If you enjoyed this video, don't forget to like, subscribe, and comment below with the types of videos you'd like to see next. Your feedback helps me create content that's both educational and exciting.